Folks. This is Professor Carberry. Um, as you guys will probably find out soon if you don't know, I'm kind of an IT dinosaur. So yesterday when I was filming follow-up on our lactic acid milk yogurt fermentation video and also the cabbage lactic acid fermentation video, I had my microphone on mute. So you have a great picture, but there's no narration. So what I thought I would do today is just do a screenshot and try my best to narrate over the video. Okay, so this might be kind of funny, but that's good. We need some humor in our lives. So folks, let me see what we can do here. So this is the milk yogurt lactic acid fermentation experiment we did. And you'll recall that we put pasteurized organic milk in one sterile test tube, and then in a that was like our negative control. And then in a second test tube, we put the milk in about a teaspoon of yogurt, which now I'm kind of thinking I might have, maybe that was not enough yogurt. And the reason is I think the milk was maybe a little bit on the older side. I love to shop at grocery outlet, right? But after the both the pasteurized milk and the milk and yogurt incubating for 48 hours at room temperature, the pasteurized milk smelled a little off to me, like maybe it was trying to spoil a little bit. And certainly when we looked at the plates, there was lots of microbial growth from the pasteurized milk, right? So hopefully we'll come back to that. I think what I'd like to do is maybe try to repeat this experiment, and maybe the variables we could do is we could use fresh organic milk, straight out of the bottle, and then we could use the fresh organic milk and then we could boil it to try to kill any, or to try to kill at least some more of the possible spoilage microbes. And then we could run each of those as negative controls, and then we could add yogurt to each of them and just see how the milk ferments, right? It'll be kind of interesting, I think, if you like to make your own homemade yogurt. Is it helpful for you to boil the milk ahead of time to kill any of the potential spoilage microbes that might be present? Okay, this is probably not good, you guys, because I'm thinking of all of these additional experiments we can do. So let's see if I can't narrate this. Again, this is going to be our milk and milk plus yogurt after 48 hours of room temperature incubation. So let's see what we can do here. Okay, so I think I was just introducing it here, like just recounting our experiment. And one of the things we're going to do is we're going to look at the milk in their test tubes. Now, this is just the pasteurized milk, again, after 48 hours at room temperature incubation. And the point was that the milk was still a liquid, right? And I think I'm going to tip it over here so you can see that it's still liquid. And obviously, I need a course on how to shoot movies, you guys. These are so unprofessional, but hopefully they're going to work for us. And then the second tube, folks, this is a tube that had the milk and about a teaspoon of yogurt. Again, 48 hours of incubation. And I was really excited, you guys, because the milk plus yogurt, it was a solid. And the reason I was excited is I thought, wow, if those lactic acid bacteria took the milk sugar, the lactose, and converted into lactic acids, acids denature proteins. And in milk, the milk protein is called casein. So I was excited that maybe, yeah, this was proof that we had a lactic acid fermentation going on. The casein proteins had denatured, and when proteins denature, they tend to tangle, and they come out of solution. They precipitate out. So they form these tangled masses of proteins, and in this case, that would cause the milk to turn solid. So I was actually pretty excited at this point. And then furthermore, folks, just while I'm yakking there, I don't know what all I was saying. On, let's see here, day 1, the milk and yogurt was pH 6. The pasteurized milk was pH 6 to 7. So I think there was maybe a little microbial activity going on there already. And then on this day 3, the pasteurized milk was pH 5 to 6. So the pH was dropping again, kind of indicating even the pasteurized milk had some microbial activity going on. The milk plus yogurt that had gone solid was at least 1 to 2 pH units lower. So the milk plus yogurt on after 48 hours was pH 4 to 5. And you guys want to remember that the pH scale, it's a log scale, so each pH unit is a tenfold different in hydrogen ions, right? So if we want to be optimistic, if we did have a lactic acid fermentation going on in the milk plus yogurt, that was a tenfold to a hundredfold increase in hydrogen ions. And again, you guys remember high hydrogen ions, low pH. Those acids are great at denaturing proteins. Now, the other point being, those acids at low pH would help denature the proteins of potential spoilage microbes. So it's in making the lactic acid, lowering the pH, that the lactic acid bacteria can stop the growth of spoilage microbes. And that's what will preserve the nutritive value of the milk in the absence of refrigeration. Now, I think I just took a whiff of the pasteurized milk, and I can remember yesterday it wasn't smelling that great. It didn't have that nice sour lactic acid smell. And yesterday I was wondering if maybe it was going to spoil, that the pasteurized milk was going to spoil on us. And another control that I didn't run initially was just the yogurt itself. And so when you smell the yogurt, it definitely smells sour, right? And in this case, folks, sour to me is not like repulsive. Sour to me, I'm thinking lactic acid. This is good, not bad. All right, and again, folks, I'm not exactly sure what I'm talking about at this point. I was hoping YouTube could get the closed captions, but I guess it doesn't make sense. If there's no audio, how can YouTube do closed captions? Okay, so here are the plates, you guys. So on day 1, when we set up the experiment, I took a loop full of the pasteurized milk and spread it on one side of the TSA plate. So as we're looking at it, that would be the left-hand side there. Just showing the pasteurized milk has a lot of microbes in it already. And again, folks, here it's just telling us that the milk pH, the pasteurized milk was pH 6 to 7. And again, lots of microbes present. So pasteurized milk is not sterile. And these potentially, you guys, these could be the spoilage microbes, right? Or maybe some of them are lactic acid bacteria. And then over here, folks, on the other side, and again, this was bad of me. I should have, I plated the milk plus yogurt mixture. And remember, there's just a little bit of yogurt, like a teaspoon of yogurt in there. And again, and oh gosh, those reflections really tough, aren't they? To me, at least initially, you guys, the microbial colonies growing on the milk and yogurt side, they look pretty similar to just the milk side. So I was thinking, well, maybe the yogurt lactic acid bacteria weren't present in high enough concentration for us to see them here. Also, lactic acid bacteria, I do believe they need a little bit richer medium than this TSA, so it might take them a while for those colonies to develop. What I forgot to do was I should have plated the yogurt, just the yogurt all by itself. I did do that yesterday, and there's not a lot of growth, or the colonies are really tiny. And again, folks, to me that makes sense. The lactic acid bacteria, they probably need a little bit richer media than the TSA. Okay, folks, so I hope that will help. And I think we have, let's see here. Yeah, I think that's it. So I'll close it right there. Okay. And yeah, and the other one we'll do is the other screen recording will be for the lactic acid cabbage video. Again, the microphone was muted, so that didn't help very much. And it looks like this might not have worked. That's a shame. Shoot. Huh, that's too bad. I don't think this worked. That's really sad. Or maybe, I don't know, you guys. Technology. technology. I'm not very good at it.